Hello learners. Today we'll discuss delta star transformation. The equation to transfer star to delta and delta to star. Okay, let us go. Let us say this is my delta connected and this is my star connection. Let us say the resistance between 1 and 2 is R12. Resistance between 2 and 3 is R23, and the resistance between 3 and 1 is R31. Okay, now here the resistance between 0 and 1 is R1, same way between 0 and 2 is R2, and here it is R3. Okay, so we'll go with delta to star and star to delta connected. Let us say that we can say R12 of star should be equal to R12 of delta. Okay, now let us imagine, let us say that there is an imaginary battery connected between terminal 1 and 2. Let us say there is an imaginary battery connected between terminal 1 and 2. Now you can see this. Since there is a battery connected, there are two paths. One is this and other is this. Okay. So here one is this part and another one is this part. At this point the current is divided. So this R12 will be parallel with the series combination of R23 and R31. Same way for star connection, here this two would be in a series since this is open, so there is no current flow. So this R1 and R2 would be in series. Okay, so suppose if I want to write down the equation for, let us say, R12 delta, it would be R12 into R23 plus R31, the whole divided by R12 plus R23 plus R31. Same way for star, if I want to write down the equation for R12 star, it would be R1 plus R2. Okay, I hope you get how this equation comes. Okay. Okay. Next, same way, if I want to write down the equation for R23 delta, then it would be R23 into R31 plus R12 divided by R12 plus R23 plus R31. That is for same way for R23 star equals to R2 plus R3. Now same way, if I want to write down the equation for R31 of delta, it would be R31 into R12 plus R23, the whole divided by R12 plus R23 plus R31. Same way for R31 R31 star equals to R3 plus R1. Now if we equate the equation of R12 delta equal to R12 star, then R12 is equal to R12 plus R23 plus R31 divided by R12 plus R23 plus R31, and R12 star is equal to R1 plus R2. So R12 into R23 plus R31 divided by R12 plus R23 plus R31 equals to R1 plus R2. Similarly, we can write for R23 into R12 plus R31, the whole divided by R12 plus R23 plus R31 equals to R2 plus R3. Similarly, R31 into R12 plus R23, the whole divided by R12 plus R23 plus R31 equals to R3 plus R1. Now adding all these equation, we will get 2 times of R1, 2 times of R2 and 2 times of R3. Same way R1 into R2, R1 into R3, R23 into R12, R23 into R31, R31 into R12, R31 into R23. Therefore, 2 times of R12 into R23, 2 times of R23 into R31, okay, and R31 into R23. So, since LCM are same, we can add it. We'll get 2 times of R12, R23 plus R23, R31 plus R31, R12, the whole divided by R1 plus R2 plus R3 equals to 2 times of R1 plus R2 plus R3. This 2 and 2 will get cancel out. You are left with R12, R23 plus R23, R31 plus R31, R12 divided by R12 plus R23 plus R31 equals to R1 plus R2 plus R3. Now if we want to get the value of R1, R2 and R3, we are subtracting this equation with above equation, then we can get now R1 plus R2 plus R3 minus R1 minus R2 equals to this R12 3 plus R23 R31 plus R31 R12 minus R12 R23 R12 R31 minus R12 R23 minus R12 R31. Okay, the whole divided by R12 plus R23 plus R31. Now this R1, this R1, this R2, this R2. So here you are left with R3, this, this, this. Okay, so you are left with R23, R31 divided by R12 plus R23 plus R31. Similarly, we'll get R2 is equal to R12 R23 divided by R12 plus R23 plus R31, and R1 equals to R12 R31 R12 plus R23 plus R31. Okay, so you can see here 4 R3 here and here. 3 is common. For 2 R12 and R23, for 1 R31 and R31. So it is the product of adjacent delta resistance divided by sum of the delta resistance. This is how we convert delta to star. Okay, I hope you get the idea. If you still have any doubt, please write on a comment section and let me know. See you in the next class. Have a nice day.